So today we are going to talk about we are still talking about emergency lighting, but today we are going to talk about design. Remember last week what we were doing is talking about the types of emergency lighting we have, where we use them, where they are located, how they are made, and now today we are going to design. We are going to talk about how we design the emergency lighting. So the BCA requirements are that, somebody has written something. Still in Akata, what do we do to him? Okay. Now, let's proceed. The three types of exit signs are, we have the left, we have the straight from here, and then we have the right. These are normally the exit signs that we normally have. So luminance requirements. When we are designing any exit sign, we have to take in consideration the luminance requirements. So the luminance of the sign shall not be less than 8 decibels. I think we talked about last week, that one. The luminance ratio of any two white or green area not more than 5 point, that is the ratio should not be more than 5.5 to 1. So the contrast of the white to green to be less than 4 to 1 also. So that is when we want to construct, when we want to design. So locations, specifications required locations for exit sign installation. So the following are the some locations referenced. So we have one is mounting height shall not be less than 2 meters. So we normally measure 2 meters from the floor, not less than 2 meters from the floor, and not more than 2.7 meters above the floor. For immediately above the doorway, if the doorway is higher than 2.7 meters. This is because when somebody gets out or somebody wants to get into a room or get out of the room, can that illumination, you can even see the way it is lighting or directly on the floor of the room. The distance or the coverage of the distance coverage of the place that is illuminated. So this is done so that it can focus exactly on that floor. An exit sign must be clearly visible to persons approaching the exit and must be installed on or above the adjacent to each other. Now, door providing direct ingress form a storage to number one, an enclosed stairway, that is passenger by, or the ramp serving as a required exit. So wherever there is an exit, that is where it should be placed. And then an external stairway, that is passageway or ramp, serving as a required exit, and then the external access balcony leading to the required exit. So the door from an outside, an enclosed stairway, passageway, or a ramp that at every level of discharge or a road or open escape. Then we have the horizontal exit, and then the door serving a service. Those are some of the requirements when we are designing that. So the viewing distance. When you are designing the emergency lighting, either for the turn right or the turn left or go straight, we have to consider the height. We have said that the exit sign, that is the height, we said it must not exceed 2 meters, not less than 2 meters. So when we are designing, the height of the pictorial element of an exit sign shall be determined by the maximum viewing distance. So you can see the height should be considered and the distance, the viewing distance. The viewing distance is the distance from where the viewer will stand so that the viewer can be able to see that emergency lighting. So a building is to be provided with adequate lighting upon the failure of normal house or artificial lighting during the emergency and provide sufficient means of warning occupants. So to assist them in evacuation process and identify exits and paths to travel. Paths to travel to exit. So emergency escape luminaries are assigned classifications to assist in the requirements. So classification and spacing. The purpose of classification is to facilitate the specification of requirement in terms of the luminaire mounting height and spacing, to simplify both designs, installation, and assessment. So an emergency escape, you can now see, this is the angle, the vertical and horizontal angles that should be left during the clearance angles that should be left during the design. So an emergency escape luminaire is assessed via the transverse, that is the CO on a longitudinal through the luminaire. Not all downlights share the same CO classification to that. So those are the specifications, the examples of the emergency lighting luminaires. This is one, and the open area luminaire lighting output. You can see the corridor emergency escape luminaire, that is another one, and how it is installed and the radius at which it is installed. And then the staircase, you can see this one moves from one level to another to another. Those are the codes and the heights for specific luminaires. And now, within meters of the approach side of each doorway requiring an exit. Now, like for example, now the distance are not greater than half the classified distance of the wall or boundary. The location of the distances, assume these are the lightings. So they have to take a specific distance that they're supposed to be installed. That is a maximum of 2 meters within 2 meters of the approach side of each doorway requiring the exit. So it is 2 meters horizontally and 2 meters up to be able to locate the lighting. So within the 2 meters of the intersection of the center line of the intersecting corridors of each change of direction. So between there's 2 meters, within 2 meters of any change of the floor on the side. So it is 2 meters both. Even in the staircase, when there is a steep, maybe a changing of level from one level to another, like for example, the stages, or where somebody can pass and maybe fall or maybe cause an injury. And then in such a manner that each flight of stairs, including the associated landings, and there you can see the stairs, how they are illuminated. Points of emphasis. Now, what do we need to emphasize when doing this design of emergency lighting? The following points of emphasis are not requirements, as the said standard, but areas for consideration and good practice when designing an emergency lighting installation. Sometimes you will find yourself doing this design in companies or in factories. So new firefighting equipment and manuals are call points. This is the way they're supposed to be illuminated. You can see the emergency lighting is directly up, so that in case of any emergency, they can be lit fully. And then near each first aid point distributor, and then we have to illuminate the safety signs of hazard areas such as kitchens, elevators, receptions, swimming pools, or the sleep hazard. And then the disabled refuge disabled facilities, toilets, and change rooms. This is the way they are illuminated. We have examination or operation theaters, first aid, and then we have electrical switch rooms. This is how they are illuminated for people to be able to see that is a dangerous place. So inspection and maintenance. How do we inspect and maintain this emergency lighting? So it is set out that the periodic inspection and maintenance procedures which are necessary to ensure that the emergency evacuation lighting system will be in a state of readiness for operation at all times. So, or at any time during the life of an installation, the duration of the operation on emergency power for every emergency escape, luminaire, and exit sign shall be not less than 90 minutes, except when applicable, and building regulations. So maintenance records shall be logged and kept on the premises at all times. Maintenance may be in form of electronic logbook or durable cover or printed. So that is now after installation. So 6 monthly and manual testing schedule. There has to be a monthly or maybe after 6 months, or that is called a semi-annually testing of the emergency lighting. Now we have the discharge test facilities, manual operated testing facilities, where manually operated testing facilities are provided for this discharge testing. The test facility shall provide for an operation of the relevant group of emergency lighting by simulating supply failure and, number one, be capable of being manually reset and automatically reverting to normal state of conclusion of the discharge test. And another one is to enter either be key operated or located in the area with a restricted access clearly identified. So automatically able to test. You will be able to test them. Now these are the warning signs that we normally have. The fire escape. In case of a fire, what does somebody do? These are some of the things that happens there. You can see now these are the exit signs. So in case of an emergency, the lights automatically come up. And when they automatically come up, they will illuminate the area and the people will be able to navigate easily. You can see now the different fittings of the control panel, the different fittings, the way they are used to be able to illuminate the area of the emergency lighting. You're almost done with this slide. So these are the types of fixtures. So sometimes you will get yourself involved in such companies that are doing maybe this emergency lighting. So you'll be able to see there. You'll be able to see the types of fixtures. We have the corridor downlight, emergency lighting. We have the open area downlight. We have the high-powered corridor downlight. We have the high-powered downlight. We have the EL10 with 4 inputs, then ELPM, that is the phase monitor unit, and the control panel transformer. They are there. And then that is the end of that slide. So I'm bringing up another slide, the emergency lighting. And this one, as we had talked about, we had said that emergency lighting is the light of emergency situation where the main power supply is cut and normal electrical illumination fails. So the loss of the main electricity could be the result of fire or power cutout. So without emergency lighting, it could lead to sudden darkness and possible danger to occupants. So either through physical danger or panic. Emergency lighting normally required to be operated fully automatically and give illumination of the sufficient high level to enable all occupants to evacuate the premises safely. So most new buildings have emergency lighting installed during construction. So the design and type of equipment being specified by the architect in accordance with the current building regulation and any local authority requirements. The British standards provide the emergency lighting designer with a clear guidelines to work to. So those are some of the codes. So we ask about the emergency escape lighting. In part, that part of the emergency lighting system that provides illumination for the safety of people leaving the location or attempting to terminate a potential dangerous process beforehand. So it is part of the first safety provision of the building and a requirement of the regulatory reform. So the standby lighting. What is standby lighting? The part of emergency lighting system provided to enable normal activities to continue substantially unchanged. So this guide does not include standby lighting. So when we talk about the standby lighting, this is a lighting that is normally there. So in case of any power interruption, it will come up. But emergency lighting is in case there is a panic or any danger. And then escape route lighting identifies the escape route that keeps it significantly lit. So this includes illuminated fire exit signs, but also emergency lighting such as emergency lighting and bulkheads. So the emergency lighting, you can see that one that we have talked about. The bulkhead emergency light is here. It is an open area, it is a high risk, the part of the emergency escape lighting system that provides illumination for the safety of people involved in a potentially dangerous process or situation. And enable proper shutdown procedures for the safety of the operator and other occupants of the premises. So consultation and design. The first stage of installing emergency escape lighting is consultation and design. We have to design. We have to go through the design stage. So the designer is responsible person and the fire risk assessor should meet and decide where the escape lighting is required and mark up a plan showing the areas to be covered, the type of power supply, the mode of operation, facilities, and the duration of emergency lighting to be provided in the emergency. So the type of power supply, we have the self-contained, which is a single point. It's normally called, the advantages are the installation is faster and cheap. This one, the one with the power supply that is self-contained, meaning it has the power installed in itself. They are normally together. They are normally in combined. So the installation is faster and cheaper. Standard wiring materials may be used. Failure of main supply due to cable burn through all automatically trigger and affected emergency lumina to come on. And then low maintenance cost, periodic test and general cleaning only required. Low hardware equipment cost, no requirement for extended wiring. Then the integrity of the system is greater because each lumina is independent of others. Then another thing is advantages. The disadvantages are the environment conditions will vary throughout. And then the battery life is limited between 2 to 4 years. It is dependent on the application. Now, testing requires isolation and observation of the luminance on individuals. So in general, the decision to use either the central battery or the self-contained system is likely to be cost determined. So if an installation has longevity, that is, it can take long, and low maintenance as priorities, then the higher initial cost of the central battery system may be acceptable. For the large project, typically lumina and installation costs. So central battery source, we have advantages at there. The maintenance and the routine testing is easier. With only one location to consider, the life of the battery is between 5 to 25 years. So you can see that the central battery source is so nice. It is dependent upon the type, and now we have environmentally stable in a protected environment at the slave lumina, and then can operate at a relatively high or low ambient temperature. Then larger batteries are cheap per unit power. And then we have the disadvantages. It has a high capacity equipment cost. The cost of installation and system wiring is high because high resisting cable is required, poor system integrity, and then localized mains failure. We have another one, now the mode of operation. What are the modes of operation? Now, it is maintained on an unmaintained is the principal consideration, which is decided by the use of premises. So the maintained emergency lumina, lumina in which the emergency lighting lamps are on all the times. That is called the maintained lumina. Maintained mode is generally used in places of assembly such as theaters, cinemas, clubs, and halls. The full list is contained in the BS 6266 code. And then the lights are typically dimmed when these premises are occupied and the emergency escape lighting prevents total darkness. So the maintained fire exit signs are also used in public spaces, even where these are well lit and offer clear escape routes. So you see that is the maintained emergency lumina. We have another one which is non-maintained. That is the modes of operation. We have the maintained and the non-maintained. Now what about the non-maintained? In the non-maintained emergency lumina, a lumina whose emergency lamps only come on when the power supply to the normal lighting fails. That is, no non-maintained is a typical mode in the workplace or similar environment in which artificial lighting is normally deployed when the premises are occupied. So the combined emergency lumina, a lumina containing two or more lamps, that is at least one which is energized from the energy lighting supply and others from the normal lighting supply. So a combined emergency lumina can be either maintained or non-maintained. Now, what about the facilities? In the facilities that they have to be used, now we have the lumina including the test device. The lumina contains self-test mode, that is for testing purposes, while another one, the lumina include the remote test device, where the system are tested remotely for a centralized panel, and another one is luminal with inhibiting mode. So a control mode used to inhibit the emergency lighting lumina from operation, thus preventing the discharge of the emergency lighting batteries at times when the building is occupied. If a mains if a mains failure occurs at such a time, the batteries will remain fully charged so that the building can be occupied when required. It is performed by an inhibitor. So high risk task lumina. For risk task area lighting in areas of high risk, the maintained luminance shall not be less than 10% of the required maintained lumina of that. So the duration. So these are most important components of this the emergency luminance. So the duration, the time required to evacuate the premises depends on the size and the complexity. For example, if we have big buildings, so it needs like maybe 1 to 3 hours. So the duration itself is dependent not only on evacuation time, but also on whether the premises are evacuated immediately. That is, the power and the normal lighting fails and are reoccupied immediately, the supply is restored. So the minimum duration of the emergency escape lighting system is 1 hour. That is the minimum. That means that once the power supply fails, the luminaires must remain on for at least 1 hour. That is the minimum. What about the minimum duration of 3 hours should be used for emergency escape lighting if the premises is not evacuated immediately. So as in the case of sleeping accommodation, for example, or if the premises will be occupied immediately, the supply restored without waiting for the batteries to be recharged. So we realize that, for example, in places like sleeping areas, like maybe in schools, boarding schools, where we have students or pupils sleeping in dormitories. So in case of an emergency, normally this emergency lighting should be able to light even for something like 3 hours. So the standby batteries should be able to withstand that illuminance or those fittings, so that they can be able to illuminate for the people to be able to evacuate the dangerous place. So emergency lighting classifications. The old NM or M classification with duration in hours has been replaced with the code consisting of letters, numbers, and letter numbers as follows. So the type we have type X and we have type Y. Type X is the self-contained and type Y is the central battery. Number two, we have depending on the mode of operation. Now, in the mode of operation, we have 0 for non-maintained, 1 for 0 for non-maintained, 1 for maintained, and 2 for combined non-maintained. You remember we even discussed about this mode of operation. Then we have the combined maintained, and further modes are also described. And then classification 3 is under facilities. It can be used including test devices, the one that have the test devices, the one that include remote test devices, and the one that include inhibiting modes, and the one with high risk task Illumina. So that is A, B, C, and D. And then classification 4, we have it ranges from 10, 60, 120 to 180. So the classification is expressed as per the following example. So like for example, we have X0, that's 180. That is a self-contained non-maintained 3-hour duration. So you see that one 3-hour duration because it is 180. So it is 180 meaning 3 hours. 1 hour has 60 minutes. And then this added as applicable at the time of installation. So setting of luminance and emergency signs. Now, how do we place them? Now we are doing the installation. We have already designed. We have looked at the mode of operation. We have looked how we name them and how we classify them. Now we want to see how we set them, how we place them. Having decided on your basic system, consideration should now be given to the setting of the emergency lighting unit and the signs within particular premises involved. This will then form the basis on which your selection of equipment can be made. So provides a graphical guide of the local location of the emergency lighting. So lighting units and signs should be cited so as to clearly show the exit routes leading to the final exit from the premises. Where the exit route of the final exit is not readily identifiable, a sign should be utilized rather than a lighting unit. Now, particularly attention should be paid to individual stairways, changes in floor levels, that is, you can see corridors, changes in floor level. I told you some areas that are very steep. Like for example, halls, like now social halls, where you might have a stage and where the people sit. So there's normally a change in level. So there has to be those emergency lighting seated there. Now the corridor intersections, we have the changes in direction, the outside of each of the final exits, the control plant rooms, and other areas, especially those of the disabled with emergency lighting, the access of fire alarm, call points, and firefighting equipment. We have to be able to illuminate them so that in case of a fire or a fire outbreak, we are able to pull this fire alarm or call points and even the firefighting equipment to be able to help us in putting out the fire. So it is not necessary to provide individual lights, that is the luminaire for each item above, but there should be a sufficient overall level of light to allow them to be visible and usable. So we should not install something that is not going to be usable. We have to make sure that it is visible and usable. So note that detailed computer point calculations and luminaire manufacturers spacing tables should be used. The above is a brief summary that we recorded that the appropriate standard is studied and gained full. So we have already done how to locate exactly how to know the coding or the naming of the type of luminaire that is going to be used. So another question is how much light? Now that we are doing the luminaire, how much light? You realize that the amount of light that is supposed to illuminate on a given area depends on the type of building. Now, like for example, we said places like theater halls. Places like hostels, they use different lightings. Places where there is a lot of activity, like industrial activities, those ones need different lighting. The amount of light normally depends with the utilization of the area or utilization of the facility. So this code BS 5266 recommends the provision of horizontal illumination on floor level along the center line of the defined escape route, that is permanently or unobstructed. Not less than 1 lax and 0.5 lax for the anti-panic areas, to exclude 0.5 meters border around the route. So in addition, for the escape routes of up to 2 meters wide, that is 50% of the route. Those are some of the considerations that have to be put in during the design of these lumina and the setting of the lumina. So the actual degree of illumination should be closely related to the nature of both the premises and its components. So with special consideration being given to care homes of the elderly, hospitals, crowded venues such as pubs, nightclubs, and supermarkets, and to whether or not the premises have overnight accommodation, that is the hotels. So the level of illumination in certain rooms and areas within a building will vary depending on their uses. All this information is contained in the appendix that will follow. In that code, you normally get it in that code. It's a standard code. So note that the above brief summary and recommended to appropriate standard studied to gain the full understanding of what is involved. So now we have installed, we have known how much lighting, now it is commissioning. How does the commissioning certificate, is it attained? So that standard or the code standard requires written declaration of compliance to be available on site for inspection. So this should detail the quality of the installation and of the conformance of the IE regulations, including the main circuit of the normal lighting system, feeding and non-maintaining fittings. So the photometric performance required is required and evidence of compliance with light levels as to be supplied by the system designer. On completion of the installation of emergency lighting system or part thereof, a completion certificate should be supplied by the installer to the occupier. And now another one is a free fire safety logbook. Now, maintenance. How do we maintain? Finally, to ensure that the system remains fully in operation, essential servicing should be specified. These would usually be performed as part of the testing routine, but in the case of consumable items such as a replacement lamp, spares should be provided for immediate use. They should be provided for immediate use. So servicing and testing. To test an emergency lighting system, a mains power failure on the normal lighting, that is circuit or individual luminance, must be stimulated. This will force the emergency lighting system to operate via the battery supply. These tests can be carried out manually or automatically. So manual testing. What is the manual testing? A stimulated mains failure can be achieved by providing a switch to isolate all lighting circuits. So the individual circuit, that is individual luminance, if the manual testing is utilized, the following points should be considered. If you are doing the manual testing, the following points should be considered. So in the system which a single switch of the whole building or a larger circuit, then after simulating the mains failure, it is necessary for the tester to walk the whole building or circuit to check all emergency luminaires are operating correctly. That is when now we are checking if actually they are operating correctly. That is after resorting the main supply, the whole building of the circuit must be worked again to check that the emergency lights are recharging. So if the emergency luminaires are individually switched, only a single walk around the building will be needed. So however, the test switches could spoil the decor of the building, and they must be of a type that is tamper-proof. Now, after the test, it is recommended that the performance of the system is logged into fire safety logbook. Then automatic testing is another mode of testing also. So what happens in the automatic testing? If the cost of the engineer's time of the disruption causes the manual testing and excessive, then self-testing emergency lighting should be considered. Different formats are available to match the particular site, that is requirement. However, the results of the monthly and annual test must still be recorded. So we have general information on about the emergency lighting. Is that according to the codes that we gave, that emergency escape lighting system specify the minimum provision and the testing of emergency lighting for different premises. Now, additional information on serving can be found in that code. Another one is the discharge test that is need to be undertaken outside the normal working hours. In buildings that are permanently occupied, the test should be faced, so only alternate luminaires are tested. And then regular servicing is essential. That is another point to note, that regular servicing is essential. The occupier stroke owner of the premise shall appoint a competent person to supervise servicing of the system. This person shall be given sufficient authority to ensure carrying out of any work necessary to maintain the system in correct operation mode. So because of the possibility of failure of the normal lighting, so supply occurring shortly after the period of testing of emergency lighting system or during the subsequent recharge period. So those are some of the key points to note. Then the following minimum inspection test shall be carried out of the intervals recommended below. So the daily emergency lighting inspection only for the central backup system. So for the central backup system, it needs to have a daily emergency lighting inspection. That is, this check only applies to emergency lighting with a central backup system. And remember, we talked about the central backup system. So in this case, there is a daily visual inspection of the indicators. No test of operation is required. So the test does not apply for emergency lighting with self-contained backup batteries in each unit. There's another one called a monthly emergency lighting testing. So on all emergency lighting systems must be tested monthly. The test is short, functional, test in accordance with that. So the period of stimulated failure should be significant for the purpose of the test while minimizing damage of that. So annual emergency testing, lighting testing. So the annual emergency testing, this is one that is done after a year. That is called annual. And then the British standards, that is the basic guide. And then then the system standards, we have the emergency lighting is now covered in series independent that can be seen forming in the hierarchy below. Now remember that we have the British and the European standards. In our country, we normally use the British standards. So the system standards for that is the lighting applications. We have the emergency lighting, specifies the luminaires to be provided by emergency lighting. And then the products and standards are there for you to be able to know the correct product. Normally, the luminaire products will be having that code, that standard code on there. So the general requirements and test, see the code. You'll be seeing that code on that. Yes, God, Anthony. Rachel. Okay. So those are now the regulations, the regulatories for the standards. You can see. So we have already discussed all the regulations, what is needed in emergency lighting, the requirements, the construction, the installation, and the setting of that. So we are going to go for and when we come back, we will be able to look at a few considerations that we need during the emergency lighting. We will look at the considerations and some of these that we looked at last week. It will be an executive summary of what we are going to talk about. So I need questions from you guys before we can break for the discussion session. Okay. So I said when we come back, we'll do a summary of what we have been learning about emergency lighting. I've already answered the question that you asked about the types of lighting that need standby power supply. And you can see now this is the construction and design executive summary of the emergency lighting. That is, we have the emergency lighting, the escape lighting, and the standby lighting there. And then we have the escape route lighting and the high risk task lighting, consultation and design. And then the type of power, we have the self-contained single point advantages are there that we talked about. We have the central battery source. We had the self-contained source and the central battery source. And remember, we said that we talked about the central battery source. In general, the decision to use either the central battery or the self-contained system is likely to be cost determined. And the mode of operation, we talked about the maintained, the non-maintained, and the combined. Then the facilities, we also talked about the, in the Illumina, including the test device, the Lumina, including the remote device, the linear inhabiting mode, the high risk, then the duration in minutes. All these things we talked about in our previous slide. Commissioning and certificate, we said how much light, we talked about it also. Manual testing, we talked about it. I think this slide we had gone through it or seen that. So I want us to go through the last slide, which is this. So LED emergency lighting systems. Well, now we are installing the LED emergency systems. You can now see how they look like. Now look at this, the way it is suspended. It is connected to that specific light. You can now see the way they are installed in that light that makes people feel safe. That is all the time. That is the emergency lighting. So these are LED composed. How to install such a thing? You can see this is a board with the LEDs installed in there, and this is a coloring. So when it lights, it illuminates this and it shines. So the system is only as good as the weakest link of its chain. So this is why we consider emergency lighting as a functional unity, from the power supply to battery, from optional use to light source, to easy integration into lighting management and building management systems. Okay. So functional unity, you can see a focused competence. Now look at the way they are installed. I'm just showing you pictures of how these installations take place. There is another one you can see there. Now everything from a single supplier. Now we are talking about the LEDs. Everything from a single supplier. The competencies of various disciplines merge. We can provide you with the entire portfolio. You can see this is a company that is able, it's called the Tridonic, that it offers the components of installing the LED emergency lighting. You can see the batteries, you can see the LED drivers, the controls, the LEDs themselves are there. Then the power supply of the emergency purposes. These various systems are eligible to supply emergency lighting installation with electricity in case of power failure. That is the separate battery group. the battery is central battery power generations or high security mains. So whether you opt for emergency lighting with decentralized separate battery solution or for a group of central battery installation with tridonic components, you will always be on the safe side about the emergency lighting. So with good reason, you can now see how this one is installed. This is a clear picture. This is the emergency lighting protect people against the panic and accident. So in case of anything, you can see people can easily see. This one is the light itself that is illuminating these exit signs. And now this one is facing right. You go right. So when the general and artificial light fails, orientation must still be ensured in buildings even for visitors. Accordingly, there are legal provisions governing the equipment, the dimensions of emergency lighting installations that will be activated within when there is no mains voltage. Okay, so emergency safety lighting. We have the safety lighting, the secondary lighting, the anti-panic lighting, the escape route lighting. So the safety lighting, so the emergency lighting is under safety lighting. So under safety lighting, we have the panic, emergency, and the escape route lighting. So the safety lighting must provide for a minimum brightness level to avoid panic in buildings and to allow for hazardous procedures to be completed and equipment to be turned off safely. Escape routes and safety devices must be clearly recognizable, thus enabling people to leave the premises quickly. Safe lighting breaks down into anti-panic light, escape route lighting, and safety lighting of high-risk workplaces. The secondary lighting. Secondary lighting provides light in places where power failures will not cause any hazard, but where nevertheless work needs to be continued. That is the secondary lighting. The anti-panic lighting is meant to avoid panic in case of power failures and enable the people in the building to clearly recognize escape routes. The required illuminance level is defined area at least 0.5 lux. We have always been saying they have to have the lux of at least 0.5. Then the step devices should be recognized clearly and used. Step routes must be illuminated across a width of 2 meters. So at least one lux along the center line of the width. You can see it there. So emergency lighting of high risk workplaces. The emergency lighting of high risk workplaces must reach 10% of the illuminance level required for the respective tasks of at least 15 lux. So 15 lux is very bright because of the high risk tasks, now like theaters that we have talked about. Control safety, that is functional testing manual for fully automated control safety. So you can see they are controlled using by automatic means. And when we talk about automatic means they're normally under programs that are able to control. So lighting enables people to leave buildings safely, helps them to find their way around and reduce accident and hazard. So accordingly, various national and international standard regulations and directions govern the operational responsibility for reliable operations of respective installations. What is required here is regular testing and function monitoring. So we have the three ranges, that is the basic self-test, the emergency lighting management, and these are the things that we had gone through, and you'll be able to see that. Now we have the systematic emergency lighting, the right answer of to any required. Then we have the high efficiency LED that can be supplied so that they can be able to light. So solutions for application specific users. We have the LEDs. You can see we continue giving the strips of the LEDs that are used for the lighting. And then the installation with separate integrated uh, emergency lighting LEDs. We can have them there. Mhm. Those are other components of the emergency lighting. So emergency lighting solutions, the complete standard, and these are still the components, the batteries that are used in the emergency lighting, combined power gear for the general lighting and emergency lighting operations, and their characteristics. So up to this point, I can say that we are done with emergency lighting. Unless there is a question, I would like to hear about the emergency lighting. It can be asked so that we can answer it. Questions about emergency lighting. Peter,
Yes.
you've managed to get in, but you came in late. Though I know last week you were there and you participated in the emergency lighting class.
Yes.
Yeah, today we have been discussing about the construction of the emergency lighting. We have been discussing about other things. We have been discussing about the construction, the types of lighting, and the power supply. Salad, I answered your question in the group. Some of the lighting installations that need emergency, that need standby power. There are things like the emergency lighting. And remember, we said that a special installation like the ones for theaters and what they don't. That is not called emergency lighting. They're called. They need standby installation in that they should not have their power off. In case of interruption with the normal power, the power should come out immediately. So those are areas with that the two areas that need standby installation. These are the emergency lighting installation and the special installation, like now those ones for hospitals and the theaters, and the high risk where there is high risk operations and works to be done. Salad, it means today your mic is not working, or what is the problem? So the module of the LEDs emergency, you can see these are different types of lighting that are being lit in the emergency. The batteries are here. You can see the high quality sophisticated applications are here. Salad,
Yes.
today you don't want to talk.
Unajua kuna watoto hapa wanapiga
Mm.
kelele ndo nikatai.
Lakini ukiweka earphones hawawezi wakasikika.
Oh.
Ah.
Si unasikia hiyo sasa? Umesikia hiyo?
Hujaweka earphones, si ndio?
Nimeweka walai.
Umeweka?
Eh.
Sawa, we are almost finishing. You can ask any question. The question you asked, I've already said that I've answered it in the portal, in the discussion section. And I've also answered it here. So I hope you are now okay. So these are notes that I've already given to you. This is how the emergency lightings will look like. You can see these are other examples of pictures of already installed emergency lightings. These one are another, they are called anti-panic escape routes and spot illumination. These ones are put at places like corridors and other places that need a special lighting. You can now see the way they look like. Those are other emergency lightings and the signs that we need in the emergency lighting. So up to that point,